Okay, so let's have a look at question 2. So we're told to write this function in terms of its partial fractions. So in terms of what we've got, we need to set up our identity. So 3r plus 1 over r times r minus 1 times r plus 1 is going to equal, or be equivalent to, a over r plus b over r minus 1 plus c over r plus 1. So at this point, just use whatever method you're comfortable with from college. So I'm going to expand it, so multiply it by the denominator. So I'm going to get a times r minus 1 times r plus 1 plus b times r plus 1 plus c times r minus 1. And then because this is identity, this should hold true for every value of r, so I'm just going to pick some value. So if I say let r equal 0, then the left hand side is going to equal 1, and both the second and the third term are going to disappear. So I'm going to have minus 1 times 1, that's going to give me minus 1. So from that I can say that a is negative 1. Okay, if I choose a different value, let's say I'll let r equal 1, because that'll get rid of all the minus ones with r minus 1 in. So r equals 1, that gives me 3 plus 1 is 4 on the left hand side, and on the right hand side I'm going to get 2b. So that tells me that b is equal to 2. And then last but not least, let r equal minus 1 to get rid of anything that's got r plus 1 in it. So then I'm going to have minus 2 on the left hand side, and then on this side I'm going to have minus 1 times minus 2, so that's plus 2, that's going to give me 2c. So I get that c is also equal to negative 1. So overall I can say that my partial fraction decomposition is actually minus 1 over r plus 2 over r minus 1 plus minus 1 over r plus 1. Okay, and then for part B we're asked to find the sum to n terms, giving it in the form of quadratic. Over that on the bottom, a, b, c have all got to be integers. And we're starting r equals 2 up to n. So we're trying to find a sum from r equals 2 up to n of 3r plus 1 over r times r minus 1 times r plus 1. Now normally there's a bit of a pattern with these types of questions, so I'm going to just throw it over here so that I can use the space on the next page for my summation. Okay, so now I'm going to rewrite this sum in terms of our partial fraction decomposition. So some of these lines you might not want to write down, especially with the time pressure that the exam bears, but I'm going to write out because I'm not too much time. So minus 1 over r plus 2 over r minus 1 plus minus 1 over r plus 1. Now, a key tip with this is you want to do this where you've got a lot of space, hence why it's on your page, because you can draw out, you're going to write the first couple of terms and the last few terms so that you can spot the pattern. A bit of a hint is looking at the denominators. So I've got r minus 1 up to r plus 1. So they're a difference of 2 apart. So we'll probably need at least 3 separate terms to be able to do this calculation. Obviously just note that r starts at 2, not at 1, because that would be 0. So let's write it out. So we put in r equals 2, so I'm going to get minus 1 over 2 plus 2 over 2 take 1 is 1 plus minus 1 over 2 plus 1 is 3. I'm not going to change how I've written it because that's going to make it easier to spot the pattern. So we're going to add to this, put r equals 3 in there, so minus 1 over 3 plus 2 over 3 take 1, so 2 over 2 plus minus 1 over 3 plus 1, which is 4. Plus, you might start seeing some patterns with denominators, but now I'm going to put r equals 4 in, so minus 1 over 4 plus 2 over 3 plus minus 1 over 5. Okay, if we're to write the next term, you can see minus 1 over 5 plus 2 over 4 plus minus 1 over 6. You can see the pattern with the denominators going down. So writing it in this way makes it quite easy to see that. Let's also write the last few terms. So plus dot 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 and then plus we can start writing out our last ones. Now I don't know where to start with this, so I'm going to try and see if I spot a pattern in my original set of numbers in this sum. And the key thing I'm looking for is, does anything obvious cancel? So if I look at things with denominator 1, I'm not really getting anywhere with the terms. Denominator 2, got minus a half plus 1, so that's not going to cancel. Denominator 3, I've got minus a third, minus another third, oh wait, plus 2/3, so that'll give me minus 2/3 plus 2/3. And then if I look at, for the denominator, I've got minus a quarter plus 2/4. So you might start to see where the cancelling is, because that and that will cancel out with that term. And then minus a quarter, and 2/4 will cancel. So we've got this weird kind of pattern in terms of where the terms cancel, not including that 2/2, sorry. So we've got like a V-shaped pattern in terms of where terms are going to cancel. So because that spans 3 of the rows, I'm going to write out the last 3 rows with n minus 2, n minus 1, and n. So if I put r equals n minus 2, I'm going to have minus 1 over n minus 2 plus 2 over n minus 2 minus 1 is n minus 3 plus minus 1 over n minus 2 plus 1, that is n minus 1, plus r equals n minus 1 in there, so minus 1 over n minus 1 plus 2 over, so it's n minus 1 and then minus another 1, so that is n minus 2 plus minus 1, n minus 1 plus 1 is n. You can also think about the pattern going down, and then r equals n, going to get 2 over n minus 1, just the exact same as what's in the formula. You might say it's a waste of time when you've already spotted the pattern, but it's useful to see if the pattern, if you want to prove it more generally. So minus 1 over n minus 1, like that should cancel, which it does. And then when you think about which terms are going to cancel sort of across the whole sum, so that would cancel. So that would cancel with the imaginary term there. So everything's going to cancel, I think, apart from that term, basically the terms that we can't get this pattern from, and these two. And does this one cancel? I don't think it does, because we can't get that pattern of 3 going on. So that's why our sum is going to simplify to. So minus a half plus 2 over 1 plus 2 over 2 plus minus 1 over n plus minus 1 over n plus minus 1 over n plus 1. So now I just need to get this overall as a sum. So I'll combine the algebraic terms, the number terms, I could combine them all, infer it together. So I've got 2, 1 and minus a half. So let me just do it like this, just to make my life a little bit easier. And then here I'm going to have n and n minus 1, so that's minus 2 lots of n, minus 2 lot over n, sorry. And I'm going to times that by n plus 1 on the top and on the bottom, and that'll be plus minus 1 over n plus 1. So as a fraction part, I'm going to have 3, I'm going to have 5 over 2 plus minus 2n minus 2 minus 1 all over n times n plus 1. Sorry, that needs to be an n. So it's times by n on the top and the bottom. And then that's 5 over 2 plus minus 3n minus 2 over n times n plus 1. And then we need to get common denominators here, so that's 5n brackets n plus 1 plus 2 lots of that, so minus 6n minus 4 all over 2 lots of n times n plus 1. So 5n squared plus 5n squared, and take away n, so that'll be plus, so it'll be minus n minus 4 all over 2n times n plus 1. Now it's worth taking the time to go a little bit slowly with this particular step because of the follow-up marks from it and actually getting the marks on that step itself. I've got a quadratic in n, and they're all integers, and I've got the 2n plus 1 on the bottom, so all things are looking good. And then hence I need to determine the sum from 15 to 20 using this. So for part C, we need to work out the sum from r equals 15 up to 20. I'm not going to write out the whole thing, but that's going to be equal to the sum from r equals 1 to 20, sorry, r equals 2 to 20, subtract the sum from r equals 2 up to 14, because I can't include the 15. So I'm just putting 20 and 14 into this formula and subtracting them. So 5 lots of 20 squared minus 20 minus 4. Divide that by 2 lots of 20 times 20 plus 1. And then do the same thing with 14 in and subtract the difference. Probably the wrong word, subtract the difference, but subtract the two terms. 14 plus 1. So we throw it into our calculator, taking again time just to make sure we're getting that mark on there, because grade bound is going to be quite close on these papers. Minus 20 minus 4, all divided by 2 lots of 20, lots of 21. Take away fraction 5 lots of 14 squared minus 14 minus 4, all divided by 2 lots of 14 times 15. I get 13 out of 210. Okay, some of you might have a calculator where you got the sigma button on there, so you can actually do, use that to check if you get time for it. Okay, so that's that question 2. That's quite a tricky pattern to spot, but drawing out enough terms, spacing out your working to make it easy for you to see, and then just taking a little bit of time so you don't lose marks on the algebra.